Hi, hello, dear students. Welcome to the idea of crystal field stabilizations, energies, and calculations, as well as the most important point of our previous discussion is stability of the complex compounds. Topic: it may be crystal field stabilization energy and calculations. But in this topic, we are going to see a few calculation part. For that only this topic I am going to discuss in this. As you all know, CFT is nothing but crystal field theory. Crystal field theory. Talking about the influence of ligand. 6 ligands are there, 4 ligands are there. The central metal is going to experience different kinds of repulsions. Means central metal metal ion containing orbitals, d orbitals, particularly undergoing splitting, and that splitting is happening at the same time. After splitting, that degenerate orbitals are said to be 5 degenerate orbitals are said to be separated into two categories in the octahedral complex. One is EZ, another one is T2Z. EZ, higher energy orbitals, T2Z, lower energy orbitals. For EG orbitals, we are going to consider 2 orbitals, and T2G, we are going to consider 3 orbitals. In this, we have dx square minus y square and dz square are coming. In this, we have dxy, dyz, dzx are coming. But in this present discussion of crystal field stabilization energy, that is interrelated with the pairing of electrons in these Eg and T2G orbitals, we have overall crystal field stabilization energy, which is given as a mathematical formula where that is small p into, or you can also write number of electrons in Eg orbitals into, for Eg orbitals, what is the rise in the energy change? That is 3 by 5 delta naught. We have to remember this point. This should be added to number of electrons present in T2Z multiplied by minus 2 by 5 delta naught, another part. So we have added 2 parts in this. To get the overall crystal field stabilization energy, we should add some number of paired electrons, means how many electron pairs are there. Using that electron pair, we can use some symbol small m, or you can write x into capital P. P is nothing but pairing energy. So here, what is exact point in the discussion is nothing but we have to know number of electrons in Eg orbital. At the same time, number of electrons in T2G orbitals. Also, we must know how many pairs are there in the electronic configuration of low spin or high spin complex compounds. For example, if I am considering an orbital electronic configuration D4 electronic configuration. If I consider D4 electronic configuration in the low spin complex, the EG will be 0 and T2G will be nothing but 4. The 4, how it will be present? Nothing but 1, 2, 3. The fourth one is paired here. That means how many pairs are there here? Is one pair is there. Total electrons is 4 in T2G. EG we don't have any kind of electron. So if you observe this calculation portion of this one, what you will get here is for this D4 configuration, number of electrons in EG, we have number of electrons in EG is 0 into 3 by 5 into delta naught. This is 0 plus number of electrons in T2G, we have 4 are there, multiplied with minus 2 by 5. Minus 2 by 5 is minus 0.4. Okay, minus 0.4 delta naught plus number of paired electrons. Number of paired electrons is one pair is there, so one pair means plus P. So if you observe this portion of the calculation in the low spin complex of D4 configuration, you will get an exact answer. That is, this is 0. 4 into 1.4 is minus 1.6 delta naught plus P. Even some of the cases here what they are talking, that is delta naught can be easily written as 10 dq or 10 dq like this, or 10 capital dq. So in such a case, you can also write this one as minus 16 dq plus P. This is for low spin complex. This is for which complex is nothing but low spin complex or in the presence of strong field ligon. The D4 electronic configuration CFSE overall CFSE value can be represented like this. In the similar fashion, if you consider for high spin complex, means in the presence of weak field ligon, the overall CFSE value can be written according to the configuration D4. The D4 we have EG 1 electron will come and T2G 3 electrons will come. So then what is the calculation portion here is EG 1 electron is there. So 1 into 3 by 5 is 0.6. So 0.6 delta naught plus number of electrons in T2G are 3 into minus 0.4 delta naught. So number of electron pairs is 0. So how many paired electrons are there means nothing is there. So it will be m value is 0. 0 into p is 0 only. So now if you calculate, it is 0.6 delta naught. This is 3 into 0.4. It is 1.2 minus 1.2 delta naught. So you can write this one as minus 0.6 delta naught, or also you can write it as minus 6 into 0.6 into 10 is 6. So 6 dq is the answer for this one. Sometimes they may give capital D or sometimes small d. So that is depends on the representation. So what is the relation between the CFSE and the pairing energy, CFSE and the number of electrons, Malin expression for the different configurations. This is D4 configuration. We have shown it to you. Now talking about a medical examination, NEET examination question on this model. Okay, so we will see a question which is asked in the NEET exam, this model. Now, if you observe a question in the NEET examination, what is the crystal field splitting energy of high spin crystal field splitting energy for low spin complex? So they are asking us D8 configuration is given for a cation. So metal ion, they are given a configuration D8 configuration. Asking for low spin, what is the CFSE value? What is the CFSE value? Find CFSE value in one of the medical examination they have asked. Let us see. First of all, what is a D8 configuration? Low spin configuration is. So here we have T2G. They are talking about octahedral. Particularly they are talking about octahedral also. Octahedral complex in the medical exam. So we have T2G is there. In T2G 3 orbitals. EG we have 2 orbitals. EG and T2G. 8 electrons we have to write in the low spin complex means in the presence of strong field ligand 8 electrons we have to write. So 1, 2, 3, 4, 5, 6, 7, 8. So we have finished the electronic configuration and now we can do calculation, that is CFSE, that is number of electrons in EG. There are 2 electrons are there. 2 into 3 by 5 is we can write 3 by 5 into delta naught plus number of electrons in T2G 6 electrons are there into minus 2 by 5 delta naught, minus 2 by 5 delta naught plus number of electron pairs, 3 pairs are there, so M value is 3, so it is 3 into P. Now if you write 2 into 3 is 6, 6 by 5 delta naught, this is 6 by 5 delta naught, this is 6 into 2 is nothing but 12. Okay, minus 12 by 5 delta naught plus 3p. So 6 by 5 delta naught minus 12 by 5 delta naught is nothing but minus 6 by 5 delta naught plus p. D8 configuration. So here we have 6 are there, here we have electron configurations are there. So you can finalize this answer. With minus 6 by 5 delta naught plus 3p. So if it is given for D6 configuration, you will get another value here 12 by 5 delta naught. So that 12 by 5 delta naught with D6 configuration asked in the one of the previous NEET exam. This is a model question only I am telling. So this is the answer for this type of D8 configuration. Okay. Now let us see what is exactly they asked. The question they asked for D6 configuration, then all the 6 electrons are present in T2G. EG we don't have any electrons, it will become 0. So this is 0. So the answer will be 12 by 5 delta naught plus 3p. That is the answer for that question. Okay. So if you observe, overall crystal field stabilization energy in the low spin complexes, how to calculate and all. This is actually asked in 2012 medical examination. Okay. Let us see another question. They have asked the question in NEET 2013. That is, crystal field splitting energy for high spin D4 octahedral complex is how much? What is D4 configuration? Crystal field splitting energy how much? Crystal field splitting energy is how much in the octahedral complex. This is also they asked in the octahedral complex. So first of all, you see in the octahedral complex, the spin they are given is high spin complex. They are talking about high spin. So high spin, D for high spin electronic configuration is EG1 and T2G3. Already explained the same model. Now if you write this one for CFSE high spin configuration, that will be 3 are present in T2G multiplied by minus 0.4 delta naught plus 1 is present in EG multiplied by 0.6 delta naught. And the other thing they are telling, if they tell pairing energy also, here number of paired electrons, electron pairs are 0, so it will be 0 into P is 0 only. So short calculation, that is 3 into 0.4 is minus 1.4 delta naught plus 0.6 delta naught. So the answer is minus 0.6 delta naught is the answer for that question. That question they have asked 2 times, 2010, 2013, 2 times they asked in the NEET examination. Okay, this is what we are going to talk in this small video. We will meet in the next video. Until have a nice day.